One small light is blinking in the dark right now, and you will see it again before this is over. You will see how a battery learns to stop wasting your time, and you will see the lab where that happened first. You will see a rock pulled from another planet that refuses to give a straight answer about whether it once held life. You will watch a machine on a warehouse floor notice damage before any person does, then decide what to do about it. You will see a shadow on a scan spotted 3 years before any doctor could name it. And you will see a chip built so memory and thought no longer live in separate rooms. None of it has a name yet. Not in this room, not tonight. Here's the rule underneath all 5. Progress never arrives as one headline. It accumulates in quiet rooms like this one, until it crosses a threshold into your life. Every lab you'll see is real. Every date is real. Every name checks out. That's the deal this channel keeps. The future isn't a single headline. It's 100 quiet Tuesdays in a lab until one of them reaches you. That blinking light in the dark belongs here first. A battery bench outside Brisbane, wired and waiting. In 2024, engineers at the University of Queensland ran a solid-state cell through thousands of charge cycles. Every cell develops hairline cracks inside, tiny fractures where lithium gets stuck and charging slows down. Their new chemistry does something stranger. The cracks seal themselves shut while the battery is still charging. No new material added, no repair crew. The battery just quietly fixes its own wiring. The lab goes quiet, just the cooling fans and one screen still glowing. In bench tests, cells that used to need close to an hour reached full charge in a small fraction of that time. You won't see a lab coat when you plug in tonight, but this is the same cell chemistry, just years from your pocket. Fewer minutes waiting by the outlet. One small daily frustration, quietly engineered away. The technician logs her final reading, then glances at a second monitor across the room. A data set from 100 million miles away, waiting its turn. That data set waiting its turn came from 100 million miles away, and on July 21, 2024, it finally spoke. In Jezero Crater, Perseverance drilled a core from an outcrop the team had named Shayava Falls. The cut face came back wrong, in the best way, rings of mineral spots spaced like a leopard's coat. Nobody on the team called it life. Not yet, that word would cost too much to say wrong. At JPL in Pasadena, a pixel instrument engineer took the core under an X-ray beam and an ultraviolet laser. No cutting, no touching. The map found iron phosphate and organic carbon sitting together inside those spotted rings. On Earth, that same pairing sometimes comes from microbes, and sometimes it's only chemistry, no life required. The room stayed quiet. Nobody rushed to call it proof, and that silence took discipline. So the mission called it what it honestly is, a potential biosignature, not a confirmed one. That restraint has a cost. The very core in question got sealed away, untouched, for a future mission to carry home. The real verdict won't come from a rover. It'll come from a lab on this planet, years from now. The engineer's hand steadies on the joystick as the readout blinks that one unresolved word, potential, and holds there. That word potential is still hanging over a rock on Mars, but judgment doesn't only wait in a lab. Right now, on a conveyor belt in a warehouse floor like this one, a robot is about to make a decision nobody typed into it. Through 2024 and 2025, logistics firms scaled agentic picking robots across real centers. One box on the belt has a hairline crack along its corner, small enough that a rushed human eye would miss it completely. Nobody programmed this arm to hunt for damage. It was trained to sort, and it flagged the box itself. It rerouted the box before a single person on that floor ever looked up. Ask the engineers, and none of them say the robot thought. They say it weighed signals and landed on a judgment. One missed crack like this can void a shipment. Competitors are already automating this exact call. Not a story about people losing a floor. a system under pressure, learning to notice. Then the supervisor watches the arm pause over a second box, hesitating in a way nobody coded. That same hesitation the warehouse robot showed you, it just walked into a hospital. At a clinic in Minnesota, a pattern recognition system had spent years reading nothing but routine mammograms. No tumor, no diagnosis, just thousands of ordinary images, one quiet Tuesday after another. Then one scan came back, and the software flagged a shadow no radiologist had marked. It's the same instinct you watched a warehouse robot use on a cracked box, noticing what nobody told it to look for. The radiologist looked again, twice, and read it clear both times. Researchers behind the tool are careful here. This is early-stage work, still running in clinical trials. Not a diagnosis, not a cure. A second set of eyes that never gets tired on the 1,000th image. 3 years later, in that same clinic, the cancer was confirmed. The data scientist circles the old shadow again and says nothing. So what changes the day the chip finally learns to see it sooner? But a shadow on a screen still had to travel somewhere to be seen. Every one of these cases shares a hidden bottleneck. For 70 years, a computer's brain and its memory have lived in separate rooms, endlessly shouting data back and forth. That shouting has a name, the memory wall, and it's why your laptop fan spins for no obvious reason. In 2024, researchers at Sandia National Laboratories tested a different architecture entirely. Instead of sending data out to a separate processor, the chip does its arithmetic directly inside the memory cell itself. The wafer in his hand has no separate rooms left. Compute and memory etched into one grid. Engineers call this in-memory and neuromorphic computing, and by 2025, chipmakers were racing to scale it. And here is the fact nobody in this film has said out loud yet. This is the chip underneath every case you've already seen. The battery, the rover, the warehouse robot, the clinic's early scan, all ran on this same chip. The hero watches a status light on the rack blink once, steady. The same rhythm from a dark room 5 chapters ago, finally with a name. That same status light is still blinking, steady, the rhythm you first saw in the dark. 5 rooms, 5 hands on 5 different instruments, and one slow pattern underneath all of them. In Brisbane, a battery stopped waiting on its own cracks and started sealing them mid-charge. In Jezero Crater, a core still holds its leopard spots and refuses to say yes or no. Not a verdict, still a question. And that's exactly why the core stays sealed. On a warehouse floor, a robot noticed a cracked box nobody told it to look for. That same quiet noticing turned up months later in Minnesota, circling a shadow on a scan 3 years before anyone else could. None of it runs without a chip built to think exactly where its memory lives. 5 rooms, 1 pattern, spreading unevenly the way spots settle across a rock. The Moz team's caution, not yet, was never a wall. It was always the word that makes waiting bearable. Count the quiet Tuesdays it took each one to reach you. That count is the real headline. The future isn't a single headline. It's 100 quiet Tuesdays in a lab, until one of them reaches you. Which one of these 5 rooms would you want to walk into first?